Hi, my name is Anna Petrovicheva, and today I'll be talking with Simon Kozlov. Simon was the first machine learning engineer at Instrumental.ai, an artificial intelligence California-based company that is helping consumer electronics companies find and fix problems better in their manufacturing lines. Before getting immersed into the computer vision world, he used to work on the reverse problem of making real-time 3D graphics look awesome. In his spare time, he was teaching a deep learning course in his alma mater, Novosibirsk State University. This episode is sponsored by Intel. Near human level of perception in an embedded device is not a science fiction, it's a reality. OpenCV.AI Kit, or OG, uses Intel Myriad X chip for neural inference and depth perception, and this combination results in almost human level of understanding. OpenCV.AI Kit is supported by a strong toolchain, including Intel's OpenVINO toolkit. OpenVINO toolkit can help you develop applications and solutions that use deep learning, and also to deploy these solutions across a variety of hardware, starting from CPU and all the way to visual processing units. Use OpenVINO toolkit to augment your OpenCV projects that need a deep learning module. It's free. Download it and try it now. Hi Simon, and thank you so much for joining OpenCV.AI for Entrepreneurs podcast. I'm really excited to have you here. And my first question to you would be, could you please tell us about the company you're working for, what you are doing there, and what is the goal of the company, what is the mission?
Thanks for having me. Really glad that such a thing exists, and really honored to be here. All right, yeah. So I work for a company called Instrumental. I'm one of the early engineers. I guess I'm the first machine learning person that joined the company, and we're in the manufacturing space, and we're trying to use all of these great advances in AI and machine learning to help build products better. So this is like a very high level. If we zoom in on the detail, is one of the things that I'm, as an outsider, learned about manufacturing is it's such a huge industry. It's a significant percentage of the whole of the world economy. There's like so many things going on. What we're doing specifically, and there's like a lot of companies doing interesting things in the space, is we're focusing right now mostly on consumer electronics segment. And what we help companies do, like most and foremost, is we help them make their existing lines run better. And usually this follows like this iterative process of, you find that there is some kind of problem with your manufacturing process, you take steps to fix it, and you make sure that the problem is fixed, and then you repeat this loop as fast as you can in the time that you have allowed. And how quickly and how efficiently you go through this loop, it like determines a lot of the success metrics of manufacturing. And we our product captures vital data during manufacturing process with like really rich data, like raw images, like very high resolution and with a predictable lighting, and AI tools that let you do this whole cycle from finding that the problem exists that you might not be aware of, to figure out what was the problem and taking steps to actually address it.
Got it. So do you see how artificial intelligence, when applied to manufacturing industry, how it changes the industry? Maybe do you see that the new lines that are being created are created with AI in mind? What is the effect there?
Right. Yeah, this is a great question. So one thing that I should preface any kind of answer, that again, the domain is so huge that I think it's really hard for one person to see it all. And my perspective is just like that part of the manufacturing process that we work with, which is again, to recap, it's a consumer electronics, and it's geared towards the beginning of the process, where you have like you just have a new product and you get it to mass production, and you want to have like a sustainable mass production. So the manufacturing is very interesting in that it's it's one of the industries that is very tech heavy. Like, for example, they're one of the primary adopters of computer vision over the years. If you look at like last 20, 30 years, manufacturing is one of the places where really embraced machine vision and all of the approaches. At the same time, it's an industry that that has certain ways of doing things, and there's like things that have been building in kind of the same way with like placeholder of high-tech technologies over like same last 20, 30 years. So it's an interesting mix of part of it really embrace for like technology for specific reason, but on the process side, it's fairly conservative. So this means that there's very different ways you can think of applying AI in the space. There's one way is to say, okay, here's an existing process, and I'm going to just make some particular part of it better. An example of that would be like there is an optical inspection, like automated optical inspection, AOI, the traditional computer vision, which solves the problem of I know the problem, I know where it happens, and it's more expensive for me to fix my process to stop making this particular defect. It's cheaper for me to catch it and remove that part from the line. So it's kind of well defined, and people think about this in these terms. And you can apply AI and machine learning towards more complicated cases, right? It's kind of filling the same spot but better. And there's certainly a lot of opportunities to do that. There's also all kinds of kind of a high level things of, okay, you have like the process and you have like a machine that does some industrial part, like for example injection molding, and it has like a particular temperature mode and like a bunch of parameters which really affect the outcome of the process. And currently there's like people who are like artisans in knowing what are you building, what should be the parameters, how do you tweak it, and things like that. So there's like companies who attempt to automate that part, and like say maybe AI could come up with like a better combination or control things to influence the outcome. What we're trying to do is some of that, but we also try to kind of impact the process of like how the things get made, meaning that changing the way that hardware engineers even find out about the problem, changing the way they like the steps that they take when they fix those problems. Because historically the field was like, imagine that you have a factory in China, or it's a lot of times it's overseas, and a company that's actually like a brand. The engineers who designed this product are in a different country, say US, again as a informative example. And you have like very limited visibility in what's going on the factory level. Usually this means that the records that you might have is like a CSV if you're really lucky. Like if you're really lucky, they will upload the CSV with 1,000 rows and columns you don't understand. If you're unlucky, you have to get there. You have to fly to this, to the factory and see exactly what's going on. And if you want to see like images or something that's what's actually happening, you really have to go there. Which made really challenging by the COVID and like the current reality that we live in, and people are adjusting to it. And I think this is one of the, if there is like an event that moved the needle on the process in the last 10 or 20 years, this is the biggest event. This made the companies much more open and rethink their processes I can't call our world post-COVID, in the COVID world.
So it seems like COVID had a positive impact to the company, right?
Well, how should I put it? Positive. It impacts a lot of ways, but it does seem that like it would follow, right? So what we're doing is we capture a lot of the vital data about manufacturing in electronic form and let people solve problems by interacting with this data as opposed to being physically on the line and then looking at things. And it would follow that this would be something very useful in these times, and we do see that it proves to be useful for a lot of our customers.
So more and more companies understand that there is a huge need to automate things that are not automated right now, right?
Something like that, yes. And as usual, it's a new thing. So so you know how coming back to your previous question, right? You can apply AI to existing problems, right? Like a problem that's already well defined. Your claim is with rise of machine learning and all of and like AI technologies, you can solve the same problem better. Or you can say, now we can solve new things, right? Things that, previously we're just doing manually or we're just struggling for. But now there's something that, can automate a lot of it, so you actually end up doing creative work as opposed to like manual work. And that usually, like, it's obviously much harder to explain and much harder to build a business around it. And in that respect, what happened with COVID in the manufacturing space made people much more open to new ideas and like thinking about like kind of from the first principles about what are we actually doing, as opposed to relying on the processes that's set for tens of years.
Got it. Thanks. I also wanted to ask you about how hard is it to apply artificial intelligence, real life products into the manufacturing space, right? So probably there are a lot of difficulties that you face when you really apply this into, manufacturing facilities that are loud, maybe dirty, something else.
Yeah, no, this is the most exciting stuff. Like for me, I'm like, my background is an engineer, and I got into like machine learning and deep learning because of all of the amazing things that's happening in a space. But for me, this intersection of like theory and practice is what's most exciting. And it's certainly, you see this every day. This is this is what makes me tick. Of like, you have a particular problem, you come up with a solution, you try it in a lab and see like how well it works, and it seems to work, and then you get it in the real world, and a reality has a way of surprising you, and no matter how many times you did it, it's still so there's something new to learn and challenging and things like that. So in terms of like more specific, what makes it fun in a manufacturing context, for example, there's like many things, but one thing that for us makes it fun is first you have like this rich data in images, and there's like problems that you're trying to find there. And this is an example of a severe imbalance, if you think about it, right? Like, we're looking for a particular defect. Let's say you want to have a model that separates defect from non-defect based on the image. And the general setting that we have is maybe you have thousands of images. The challenge is you can't get more, because this is how many units were built at that point, right? You cannot go outside in the world and capture more data of the next phone that's being built. There's been only 1,000 of them built. And say your defect, like a realistic defect count, is something like, 1% is you're really lucky. Like 1% is a huge defect, super important to fix, things like that. So it's like everyone knows about it. The defects that matter at this point are also 0.1% or 0.5%, because if you have a 0.5% defect and you don't fix it and you create a manufacturing line, 0.5% at the scale of the billions of phones is like overwhelmingly bad. So this means your model receives like, say, 1,000 units, right? 1,000 images, and if you're lucky, 10 of them are defects. And this is where you're lucky. In practice, you don't get lucky, and there's a lot of value when there's like 5 or 4 or 3. So how do you do that, right? Like, this is like something, what is it, they don't teach you at school, right? Like, there's a way to deal with imbalanced data, but what if it's that imbalanced? And there's no way to get more. So that's one interesting challenge. Another challenge, just as an example, right, is usually the images we work with in like deep learning space, right, the inputs to a lot of the classification networks are like 224 by 224 or around that number. The realistic image that you can get is something like 25 megapixels, right? And it raises a question of, okay, I have this image. I know some units like failed or not failed. How do you even start with that? Because like the size of the defect, of the actual defect, is maybe like 50 by 50 pixels. And if you resize the whole image into like, then you won't even see it. So and this kind of happens everywhere. And like kind of this intersection, it's like the general theme is it's the same challenges that people talk about like in kind of academia, or like people struggle with not struggle but investigate with deep learning, but the real world has a way of pushing it to an extreme on some axis that you don't expect. And then it becomes like an interesting engineering and research problem of how do you do that.
Yeah, that's exciting. I mean, I also love that. When you read some state-of-the-art papers, they typically operate on large data that is pretty much balanced. And when you start applying it to some real-life problems, this is what you actually see. So yeah, thanks for sharing that. I also wanted to ask you about your teaching experience. So as far as I know, you were teaching a course in artificial intelligence and machine learning, and you did it online remotely even before it was a mainstream way of teaching artificial intelligence and also other courses in universities. So could you please tell us about this experience, and what would you maybe recommend to people who study online right now?
That's a great question. So the story is I come from Novosibirsk State University. It's one of the, I don't know, I gotta look at the rating, but somewhere like top 3, top 5, depending on the year, engineering schools in Russia. And like this is my alma mater. Since then, I moved to US and worked in the companies large and small. But I was in back of my mind. There's like a background thread that like runs in, at least in my mind, about like, dude, you gotta give back somehow. Like this was your school. I got it for free, which is amazing. Now that like looking at what happens in a larger place in the world, and specifically US, the fact that I got this kind of education for free just because I had good grades in school and passed the exam is just beyond fantastic. And I always thought of like, okay, there is this kind of, I don't know, underlying, how do you give back to all of this? And the opportunity that presented itself was one of the, I think it was my professor that visited at some point, and we were talking about it. I like at that point I've been working in deep learning for a couple of years, and I was really excited about it. And I don't know, maybe people, so like some of your viewers could like resonate with this, but there's like, some kind of people where they're excited that can't shut up about it, and they tell about something that they like to anyone that they meet. Anyway, and we talk, and he's talking about that it's really hard to get like, I think it was something like, this is amazing. Why don't you guys teach it? Like, why isn't there like a course? And it's like, yeah, we're trying to find somebody who would teach this for like a number of years, and no one wants to do this. And I'm like, like, would you like me to teach? Something like this. I don't remember. There was some alcohol involved. And I think this is like similar to a lot of the things in my career. They were basically desperate enough to accept me. It's not like I'm a professor. It's not like I do research in this space. I work in this space. But I guess they didn't have a better option. So I ended up teaching the course, which was I'm in Silicon Valley. They're in the middle of in Siberia. And yeah, I like it was streamed to YouTube, which was very fun. Like imagine that like you have like the first lecture is like there's like an auditorium, or there's like a place where there's like, and there's people coming in, and there's like layers, and there's like maybe 100 people who like signed up for this course. And there's like, you sit in, there's like a big projector, and like your TA opens a YouTube link and hits play. and this is like a live stream with the with the audience, which is kind of surreal, right? It's surreal. It was surreal in 2019.
But right now, yeah. What is the time difference between you and the students?
Oh, great question. So it was late at night for me, and it was morning for them. And halfway through the course, the light savings time kicked in. So Russia, I don't know what the situation. I think they just don't have the daylight savings, and California still does.
Yeah.
And I was like 11 p.m. and then it suddenly became midnight because like the daylight savings.
So I guess at some point when like the daylight savings came, everybody missed the lecture. Or did you miss it? No.
No, they don't have a daylight savings. Everything is good. It's just on my time, the lecture used to start at 11 p.m. and now it has to start at midnight because my time changed and their time didn't. So they're good.
You were moonlighting,
it's all on me.
Right? This is what you call moonlighting.
Yeah, big time.
Yeah.
Big time.
Okay, so any advice to people who learn remotely right now? Maybe some some tips and tricks that you learned from this experience.
Right. So, a couple of things come to mind. Again, gotta preface it that everybody's learning style is very different. So I know there's people who like learn from practice and nothing else. They really need to feel it with their fingertips to get a feel for it. I'm the kind that likes some structure. So I like to I think like university course is like a perfect structure where there's like some theory, there's some practice, and then you're ready to take on new things. So what I'm looking for in a university course or like an online course always, I think like it has to be a full set of three things. There has to be lectures, and it's video and not just like the text. Somehow for me, this video, like the rich channel of somebody explaining it like works really, really well. Second thing, there has to be homework. And like you need to get value from the course, you gotta do the homework. Like if you don't, then it's like 50% or more, probably more of the value disappears. And finally, you gotta have a community where you ask questions, you ask them if they're stuck, or like if you're stuck, you help other people, you kind of get involved. The nice things about online courses is those three things like don't have to be from the same place, right? Meaning, well, okay, so like lectures and homework probably comes from the same place, but the community, there's a lot of options, right? So you can organize this community by yourself by just asking friends or finding buddies who you like go to this course with. You can join one of the existing online communities and ask them questions. There's a bunch of great communities both in Russian and English. So for me, like those three things, all of them are essential. If you have a buddy that you can like go through this course with, this is even amazing. I passed some of the courses with my wife, and that was like an awesome experience. Not sure if everybody, probably not everybody can do this with their wife.
Cool. I mean, this advice on the community, I think, is very, very important one, because this is something that kind of makes it personal for you, makes you really finish the course that you started maybe on some online platform, right?
Right. Yeah. And another thing, well, I guess, so there's like a lot of like social feedback. So yeah, there's like a lot of things. If it's a vibrant community, you start learning tangential things to it, what other cool things are happening in a space. You make great relationships. Like for me, again, I'm a nerd. So it's like I'm socially, how should I put it? I'm not the most loud person in the party. Let me put it this way. So you can kind of, if you look back at kind of a couple of years, I can see kind of circles of friends that I made because of the changing interests. So I have like, and I like, for me, it's like a very natural and a pleasant way of meeting people and kind of maintaining connections. And it turns out a couple of years down the road always pays off.
Cool.
I'm on this podcast, for example.
True. Okay, so I also wanted to ask you about your your career path into artificial intelligence and deep learning. So as far as I know, you worked at as a game dev engineer, and I wanted to ask you what was the transition path to machine learning to artificial intelligence. Could you please share your experience on that?
Sure. So there's I guess there's two parts of it, which is one is kind of why the hell would you do it? And second is how would you do it if you decided that this is what you want. So I'll start with the first part, if that's all right. So I made games, and it started with 3D graphics, and I really liked all of this shaders, GPU, like all of the cool things to make things run fast, and kind of grow into thinking about the platform and the product overall. If any of you have kids of a certain age, if you know the word Roblox, blame it all on me. It's like you can I am the problem, even though obviously there's a lot more people working on it. And at some point, I call this middle age crisis for engineers, which is you worked at some space for 10 years or a little more, and it kind of it feels not as exciting anymore for some reason. And I think there's a combination of you learn less new things, and for me it was also kind of, if you start looking at the larger picture, in the end when you work in games and you work in even develop graphics or cool technology, in the end your product is entertainment. So you're kind of an entertainment industry, so it means your final product is this fleeting feeling of someone feeling awesome. And this is great, right? This is a very valid product that you can sell, and it will make people's lives better. But I was kind of feeling that I want to see my product being something more tangible, something that stays in the world, and not this fleeting feeling that just disappears after after it happened. And I was tired of the kind of graphics and games as a space. And I was looking at what else could I do. I was looking for this excitement of learning something new and working on something that at that point felt more meaningful. I looked at a bunch of things. What did I look for? I was interested in AR. I was interested in robotics, and I even looked at blockchain a little bit. But kind of machine learning, the intellectual part of the blockchain. But kind of machine learning, this has coincided with the rise of deep learning. Kind of felt right. It was like love at the first sight. So this is why. this is the why question. The how question is wasn't rosy as well. So at that point, I had 10 something years of experience. Turns out that switching careers as a somewhat senior engineer is not easier, but might be even harder than as a junior engineers. So because so you want to work in machine learning, and you apply to work on it. People okay, you're a senior engineer. We expect you to be a senior machine learning person with years of experience and knowing everything about the space. So, and you're clearly not that. So we're not gonna, what's, and even it turns out even trying to make a claim that I know I'm not senior. I'm okay with that. I'm okay with reduced pay. I want to be a junior person learning about the stuff. Doesn't work as well. So it just doesn't click in people's minds, and they just don't talk to you.
It's hard.
Which was surprising. So downshifting is not a thing that often happens. Yeah. So the question is, what do you do? What do you do? The solution for me was similar to what I alluded before. Is you got to find a company that is so desperate to hire someone, then they would allow you to work on things that you really you really want. For me, the first example of this was Dropbox. Dropbox is an amazing company, and what makes Dropbox different from any other company that I ever worked for is a unique combination of how kind of both qualified and friendly people are. So it's like the bar is for hiring engineers is extremely high. I'm sure for all of the other people who join Roblox, like Dropbox, it is very high as well. And somehow they manage to like hire amazing engineers and still first not hire assholes and kind of have the company culture that they're friendly with each other, which is amazing thing to experience. And this is why, like, naturally they always have a problem with hiring people, right? Because like if your bar is super high, then obviously you will it will be a challenge. And so I applied as an engineer to the ML team, and basically they're like, it's so hard for us to hire engineers. So if we find someone who's like we feel could be an engineer here, you can use all of your negotiation leverage, not towards the better salary or like a position or anything, but you use it towards, I want to be on that team, and I just want to be engineer on this team, and I want to absorb what's happening. And this is how I got to the ML team. Most of the stuff that I worked on was far from ML, so it's like there's always enough engineering things to do, and you can do it. I work on some, but you like absorb things that's happening around, and spend like a little more than a year there. The next step, if you're interested, is I joined Instrumental as the first machine learning person. As you can imagine, the story was that they were trying to find a machine learning person to join a startup and actually have experience shipping stuff for a while, and they couldn't. and this is why we talked, and they gave me a chance, and working out so far.
But you sound like you just got lucky, but I believe that you put a lot of hard work into that to learn a lot, to get new skills, right?
Absolutely, and my kind of, it is a lot of this is luck. A lot of this is absolutely luck. The other part of it is you keep trying, right? You keep like both learning new skills and applying to a lot of companies until you hit this magic desperation combination. I'm kidding, but like maybe what I'm trying to say is there is part about kind of growing your skills, right, and like being able to perform the work. A lot of it you can only kind of a lot of the skills you can grow only by doing things, by having an opportunity to work on something real. And for a lot of the kind of positions and like outside world, how they look at you, they might not know that you have those skills, right? Like because it's hard for them to measure that. They look at your background. So and one kind of this solution that worked for me, I'm not sure if it works for everyone, is to find like an opportunity that is like maybe a loose combination of those things, and you gotta keep trying a lot to find the one where like they will give you a chance. Basically, to find somebody who would give you some kind of chance. And it's a privilege to receive that opportunity, and obviously there's promise on your part to fulfill, but by changing a couple of these things, this could smooth out the curve from transitioning to kind of what you've been doing before to a very different like domain to work afterwards. Am I making sense?
Yeah, totally. And then when you got this opportunity, you definitely have to work hard, learn new things, and don't give up, right? Obviously, when you don't have this chance with one company, you just have it. Maybe you will have it with some other company, right?
Right. Or another team, or another set of circumstances.
Yeah. Okay, so I really enjoyed talking to you. Thank you for being on our podcast. That was my last question for today, and I wish you a very good day today.
You too. Thanks for having me.
Thank you so much. Like our guests on the show, I don't just enjoy talking about computer vision and artificial intelligence, they are also what I do for the living. At OpenCV.AI, where I work as the CTO, we help our clients create incredible new projects and deliver them into real life using our decades of experience in computer vision and related fields. Of course, it's not just me. For example, Dr. Gary Bratsky and Dr. Satya Malik are part of our team. But it isn't all just fun and games. For example, we created a number of medical solutions that help save human lives. OpenCV.AI is already helping our clients from all over the world bring spatial AI and edge AI into our everyday lives, thus making the world a smarter and safer place. You can learn more and contact us at OpenCV.ai.